Hey, hi, and welcome back to the part 2 of Introduction to Capacitor. I hope that you are enjoying this training, and I assure you in upcoming videos you will enjoy even more. Okay, so that's my promise. Okay, now let's start with this video. So in previous video we completed one purpose of capacitor, which is energy storage. Okay, and in this video we will complete the second purpose, which is capacitor as a filter. Okay, so let's start with this video now. So to understand how capacitor work as a filter, let's consider this circuit and let's try to understand this part slowly and in step-by-step manner. Okay, so in this circuit there is a PSU, and this PSU is basically powering this circuit. Okay, and this PSU is actually nothing but the power supply unit. Okay, which is basically an AC to DC converter. So it takes 230 volt AC and generates the 5 volt DC on the output side. Okay, and then that 5 volt DC is provided to this particular circuitry. Okay, but let's consider that the output of this power supply unit is not pure 5 volt DC and it includes some noise. Okay, and we don't want that noise to travel towards this circuit because we want to power this circuit with pure 5 volt DC. Now this noise is actually nothing but the AC components. Okay, now what do I mean by AC components? See, AC components are actually nothing but all the signals or all the frequencies present in power signal other than the DC components. Okay, so from power supply we are getting both the DC as well as AC components. Okay, but to power our circuitry we just want DC components. Okay, and we don't want the AC component. So we need to eliminate these AC components from the power line, right? So how to do that? In such cases we actually use capacitor. So this capacitor will bypass AC components towards the ground, and on the output side of capacitor we will get a pure 5 volt DC. Okay, so this is how basically capacitor eliminates the noise. Now you will have a question, how exactly capacitor bypasses noise towards the ground? So let's try to understand that now. You can consider capacitor like a component which provides variable resistance. Okay, and this word resistance is actually not appropriate when we deal with the capacitor. Instead of that, we actually use a word capacitive reactance. Okay, but just for the sake of simplicity and to understand how exactly capacitor filters the noise, let's consider that it provides variable resistance. Okay, there is actually one animal which is called as chameleon, and it actually changes the color as per its surrounding. Okay, in the same way, capacitor changes the resistance based on the property of signal. Now what resistance capacitor will provide, it actually depends on the frequency of signal or the frequencies present in the noise. Now for some frequencies, capacitor actually provides very low resistance, and for some frequencies capacitor provides very high resistance. And for what frequencies it will provide low resistance and high resistance, it actually depends on the value of capacitor that you are using. For example, for X frequency or for a range of frequency, if it provides low resistance, then those frequencies will be bypassed by that capacitor towards the ground. The reason is signal always chooses the shortest path to reach towards the ground, and also it chooses the lowest resistance path. As a result, the signal with such frequencies will be bypassed by the capacitor towards the ground, and it will not travel towards the circuit. So this is how basically the capacitor filters out signal with a specific frequency or a range of frequencies. In the same way, for some frequencies capacitor provides high resistance, so those frequencies will not be bypassed by the capacitor and they will travel towards the circuit. So always remember, whenever you have to remove a noise from the signal or power line, there you have to check what's the frequency, and considering the frequency, you have to select the capacitor that provides low resistance path to those frequencies. Okay. After that, I told you whenever we deal with the capacitor, we don't use a word resistance. Okay. Instead of that, we actually use a keyword capacitive reactance. Okay. Because resistance is basically the property which is exhibited by the resistor to provide opposition to the current. Okay. And capacitive reactance is basically the property exhibited by the capacitor that provides opposition to the signal. So capacitive reactance of capacitor is responsible for the opposition provided by the capacitor to the signal. Okay. Also, capacitive reactance of capacitor decides whether the signal will be bypassed or not. Okay. So I hope that this point is now clear. But we actually live in practical world. And in practical world, when you purchase the capacitor, it's not just the capacitor. Okay. It constitutes of resistor in some amount, then the inductor in some amount, and ultimately the capacitor. Okay. So this is how the capacitor look like in practical world. And the resistor present in the capacitor is actually called as ESR, which stands for equivalent series resistance. Okay. And it exhibits the property of resistance. Then the inductor present in capacitor is actually called as ESL, which stands for equivalent series inductance, and it exhibits the property of inductive reactance. Okay. And in the end, capacitor exhibits the property of capacitive reactance. Okay. So the combined effect of resistance, inductive reactance and capacitive reactance actually contributes to the impedance of capacitor. And out of all the three properties that I mentioned, the effect of capacitive reactance will be dominant in the impedance of capacitor. Because we are dealing with the capacitor, so it's obvious that its effect will be dominant. Okay. So now this is very important point. Always remember, whenever you will deal with the capacitor, we will deal with the impedance of capacitor. Okay. Not just capacitive reactance. So impedance of capacitor will decide whether the signal will be bypassed or not. Okay. So if the impedance provided by the capacitor is low, then the signal will be bypassed by the capacitor towards the ground. And if the impedance provided by the capacitor is high, then that signal will not be bypassed. Okay. Now the question comes, how I will know for what frequencies capacitor provide what impedance? Okay. So this question is actually related to impedance versus frequency plot of capacitor. Okay. And the answer to this question is, you need to check the manufacturer website. Okay. Actually, some of the manufacturer provides the impedance versus frequency plot and some of them don't. Okay. So Kemet is actually one such manufacturer that actually provides impedance versus frequency plot. So what you can do, whatever value capacitor you will use, you just come to this website and check the impedance versus frequency plot for that particular capacitor. Okay. So if you are using a capacitor from some other manufacturer, although the value is same, but impedance versus frequency plot for that particular capacitor will actually, it will be similar to the impedance versus frequency plot that you will get on this particular website. Okay. So I hope that this point is now clear. Alright, so that's what I wanted to tell in this video. And I hope that every single thing that we discussed is now clear to you. But we are not yet done with the filtering part of capacitor. Okay. We are left with the impedance versus frequency plot. So I will explain you impedance versus frequency plot in next video. And we will try to understand every single thing in detail. Okay. Alright, so I will see you in next video, which is Introduction to Capacitor Part 3.